I'm here to introduce our next speaker, Dr. Nestori Syynimaa. I hope I pronounced that correct. He's one of the world's leading researchers and experts on Azure AD and Microsoft 365, and also the creator of AAD internals. With over a decade of experience in Microsoft Cloud Services, he has been recognized as a Microsoft certified trainer since 2013, an MVP since 2020, and Microsoft Most Valuable Security Researcher since 2021. So please give a warm welcome to Dr. Nestori.
Thank you. Can you hear me all right? Okay, good. Jesus, this room is big. But I used to sit on the two first rows, so I didn't understand that. Okay, so welcome to my talk, Deep Dive to Entra ID Token Protection, Token Theft Protection, not Token Protection. And these are kind of things I'm going to cover. And so yes, so thanks for introduction. I'm not MVP or MBRP anymore because I joined Microsoft, so I had to let them go. But anyways, so I work for an organization in Microsoft called Mystic, or Microsoft Threat Intelligence Center. And I'm there doing like identity security research. And I have like two roles, or two things I need to do. So one is like I'm trying to find vulnerabilities before the bad guys do. And I've done so, you're welcome. And the second one is that I'm talking in conferences. And this year I'm not talking in the US, so I'm having this the non-US till 2025. And I need to leave right after the talk because I need to fly to Rome. There's a conference there, and then from there I fly to Canada, and hopefully the last one will be Eco Party in Buenos Aires. And when you are doing like a lot of talks, anything can happen. So this happened to me in Black Hat Asia, but thank God it was 15 minutes before the talk, so I was able to cover that. And then also some funny things happened. So this is from a couple of years ago from a conference from Germany, where I was pointing something, and then a gentleman here in the first row said that would be nice for meme. So this has been used ever since as a meme. And the same conference was 2 weeks ago, and here's something from there. So, okay, but then to the business. So. Token-based authentication attacks. So let's start with that. So what that covers? And we have three key concepts. So we have users who are using services. Then we have service providers who are providing services. And then we have an identity provider who is providing identity and access management. And these can be like the same program, may have all the roles, or just some of them. But yeah, these are roles. And how the cloud works in one slide. So you as a user, let's say that you are using Outlook and you want to access Exchange Online. So what happens is that you go to Entra first and say that, hey, this is me, Nestori. I'm using this device maybe. I'm using this client, Outlook. I want to access resource, Exchange Online, and I need to prove my identity. And if Entra is happy with that, Entra will give me access token. Oh, yeah, this is a good point. So Entra doesn't know anything about me. I need to tell everything, like who I am. It doesn't know. Entra knows my IP address, but that's it. It doesn't tell anything. Okay. And now, if it's happy, you will get access token. And with that access token, then you can go to Exchange Online and provide that token. And then, because it's signed by Entra ID, by using a certificate that everybody is trusting, then Exchange Online accepts, okay, you are who you are. So you're welcome. So that access token, or any other token, is important because it contains information about you. So like here, Exchange Online doesn't know anything about me. It only knows what's inside that access token, and I believe it's in that. So that tells you who you are and so on. What you can do, for how long, and so on. So here's a quote that hackers don't break in, they log in. So if they have that token, they don't need to break anything. Just use that, and hacker can be you. Okay, so this is from our report. Never remember the name of the report, but it's Digital Defense Report of something from last year. So let's see how this works. Okay, so we have things here like 99% of all attacks are password attacks. So it's a big one here. And then under 1% are these things. So we have adversary-in-the-middle attacks, we have token theft, and then we have like infrastructure compromise and so on. So I'm trying to cover pretty much everything here, but only those things that are related to tokens. So here's another famous quote from Tom Lambert, who is our vice president on security. So basically what he's trying to say here is that there are multiple means to get to your end, so you need to be aware of all of those, so not just one or two, but you need to cover everything. So that's basically what I think he's trying to tell here. So here is a graph for all token-based authentication attacks. And let's start with the up here. So do you have access to secrets? And by secrets, I mean secrets which you use to sign those tokens. Like, for instance, there was breach a couple of years ago, you might remember, that our token signing key was compromised. But that's usually for nation-state actors, so you can steal secrets, then you can forge tokens offline, so there's no login whatsoever, and then you can use the token. Or if you don't have access to tokens, then you can steal tokens. Unless you are Dirkian, so then you can just forge tokens offline. So I think you heard about this last week or something, so it was quite interesting thing. Okay. But yeah, so I'm covering this token theft like part here. So what is token theft? So basically there are a couple of things that you can do. So we call these sometimes like network-based attacks, so we can use adversary-in-the-middle kind of thing. So who has heard about this attack? Okay, so you are quite familiar with that. So usually when you go to login, you go to login.microsoftonline.com, but you might get a link that goes to either that is similar to that, not the same, but it goes to something like evil things or whatever thing you are having there. And after you log in, you can have username and password, or tokens, or session cookies, or whatever. Does anybody want to see a demo of this? Okay. Let's try that. And I hope that the network is working because I'm doing live demos. So. It's nice. And I can almost see there. Good. Developer. Okay. So what we can see here is a URL that is almost correct, but there's 0 there. Okay? So let's copy this. And now we go to the victim, who is right here. Okay. And we're going to choose Chrome. Then we're going to paste that, and then we're going to hit Enter. And now what happens is that nothing happens. Why? It's actually quite hard to see there. Connect, reconnect. It's better. And it worked just fine when I was sitting there during the... Okay, well, I can't help with that, I suppose. So no demo for you guys. Or bad demo. But anyways, you would have seen my password there, but now you're going to miss that. So let's continue with the slides then. So let's see how my demos goes today. Okay, so now then what to steal from endpoint. So other thing is that if you can have like that kind of adversary-in-the-middle attack is that you need to compromise the endpoint. And you can steal stuff from users' endpoint, and what you can steal, so there are different things. So first is keys, but it requires that your endpoint doesn't have like TPM, and you need to have local admin permissions. And with those keys, you can prove the identity of the device. And depends what you are, well, yeah, identity of the device. And then you can steal other things, so ESTS auth cookie, so that's like a single sign-on. Then we have PRT cookie, which allows you to get access to any kind of like a service for a certain period of time. And then you have the token, and that's valid, it depends on the token. And what kind of tokens you can then steal? So we have the PRT or primary refresh token. Well, actually that token isn't that like private. You can get that easily. But the session key is the one that it's required to use that PRT. And again, you need to have a computer that doesn't have a TPM, and you need to have local admin to get that. But if you have that, you have access to anything that the user have access to. So it proves the identity of the device and the person who is using that. Then we have these things that you only need to have like user permissions, so family of refresh tokens. So this is kind of like a refresh token. So let's go back. So what is a normal refresh token? So when you, let's say me, I want to access Xsense Online using Outlook, I will get back access token, which is valid for 1 hour, and then we have the refresh token that is valid for 90 days. So whenever that access token it's like gets old, I can get a new one with that refresh token. But that refresh token is usually for one resource, one client. But this family of refresh token is a little bit different. So there's a certain number of applications, first-party applications from Microsoft, that if you are part of that family, you get access token to that, you can get access to, refresh token to that, you can get access tokens to every other client in that family. So it's a little bit more powerful. And then the least, but well, the last but not least is access token. And that gives you access to a certain resource using a certain client for 1 hour or up to 28 hours, depending on if you are using a thing on continuous access evaluation. And we're going to see that later on. Okay, so next demo. Let's see how this goes. So, hey. Look at that. Now we can do this anyway, so. Okay, that was a typo. Okay. And of course oh, do you want to know? No, thank you. Of course I didn't use my correct password, but hello BruCON. But anyways, if that would have been like a correct password, I would have now have the access tokens and session cookies for that user, so I could be him or her. Okay, but the next demo, how to steal stuff. So for that purpose, I'm going to use the best browser in the world, Edge. So I hit the hacking button or F12, which shows us the developer tools. And I'm going to now do this. So I go to portal.office.com. So I guess the network is that good now. Yeah. So we're going to have demo effects again, but what we're going to try to find is bearer, EY, and let's see, can we see anything? No, no, there's a typo even. Yeah, so the network is not working that fine. But anyways, so if you're able to compromise the user's endpoint as a just user, so let's say your colleague wants to coffee and leaves the laptop open, you can go there and just copy those tokens, and then you can be him or her. So it's that simple, so it's not difficult. So you don't need to have like a world-class hacker to do this kind of stuff, so you just need to be able to open the browser and you're good to go. But as we can see, if the network doesn't work, this doesn't work. Okay, so let's then try something different. So here we are now local admin, and we have compromised the endpoint, and this endpoint doesn't have TPM. So I'm going to try to steal the identity of the device and the user. And for that, you need to install my PowerShell module. And now this one is called for endpoints, and it doesn't work because there's a virus. Okay. But because we are hackers, we can do this. Okay, let's try again. Ah, that's true. That's better, okay. So, in order to get that PRD and session key, you need to know user's username and password or PIN key. And if you have compromised endpoint, you probably know those. So, like this. And let's hope that the credentials were correct. There was a typo, okay. Oh, you got to be kidding me. So I usually do this beforehand, just to avoid these kind of things. But okay, let's try again. Like this. Okay, so now we have the session key and the primary resource token. And now with these, I can take this off of this computer, except now because the network doesn't work that well. So I could then use this like offline. And this combination of the primary resource token and session key, that proves the identity of me as a user and also the device. So I can say that I'm this nice compliant device, even though it's not. Okay? So that kind of tells us the attack paths for token theft attack. Okay? So do we have access to endpoint? If we don't have, we need to use Adversary-in-the-Middle, and then we can steal tokens and use them. Okay? But now if we have access to endpoint, are we admins? No. Then we can only steal tokens and use them, right? But if we have admin permissions, we can install malware, we can steal secrets and tokens, and use that. And with the secrets, like here, this PRT and session key, we can acquire tokens and then use them. So this is the whole thing that we need to protect against. And let's say we have some best practices for that. Oh, there's those techniques which you can click the link. It's safe to click, no worries. So we have some security best practices with Entra. And the first one is like conditional access policies. So this ensures that tokens are only used from trusted networks and devices. We'll see if that's correct or not. Then we have token binding. Well, that's in the industry called as token binding. We call it token protection, don't ask. And this prevents token replay attacks from different devices. We'll see if that is true later. And last, we have continuous access evaluation. So basically, that is like continuously evaluating the session. So usually access token is valid for 1 hour. If you reset your user's password, that access token is still valid. But this prevents that, so if password is reset or something like that happens, we can invalidate that token. So next I'm going to cover these. So let's start with conditional access policies. So how this works. Okay, me as a Nestori want to use Express Online again with Outlook client. I go to Entra and say that, okay, this is me. I'm using this device and so on. And then if Entra is happy, it's evaluating all the rules we have. So we might have rules like you need to come from certain network segment, you need to have like compliant devices or Mac OS or whatever. You can use as complex rules as you want to. And they are evaluated. And when that is okay, you will get access token, then you can consume the services. But remember that this happens before authentication. So if you are able to steal the token, that's already like a valid thing. So you can use that, even from different devices, because the token contains information. And Entra doesn't know anything about us except what is inside the token. Okay, so it means that conditional access policies may protect against adversary-in-the-middle. And why is that? Why I say it may? Because it depends how you configure your rules or policies, so it's up to you. And you can also defend against acquired tokens. How? Well, you can say that, okay, even though that I have PRT and session key, I'm coming from somewhere, we can require that you need to come from a trusted location, for instance. So you can't use that outside that network segment. Let's see if the demo works. So we have still this running, right? So next I'm going to show you that we have a conditional access policy. So somewhere here. So we have a policy that says that require compliant device from Diego. But yeah, sorry about that. So we turn it on. So network seems to be working, that's good. So now, because we are requiring that Diego needs to use compliant device, so even though there's Chrome, I need to copy the URL again from here. Okay, at least it tries to work. Let's click that one. Now we're using correct password. It will come there eventually. Just give it a second or two. Okay. So there's a window that says that you can't get in from there. Okay. And why? Because the computer running that evil thinks it's not that very compliant because it's my attacker machine, so that's why I couldn't get in. So yeah, conditional access policies can be used to prevent that, at least partially. But again, it depends how you configure the conditional access policies. But yeah. Let's continue. Okay. Then to token protection. So it supports only certain clients and resources, so it's not everybody. So for instance, you need to have like a supported device and client, like OneDrive, Teams, and so on. And if you want to use this, you need to use conditional access policies. Well, currently, sorry, I think, I'm not 100% sure, but those are like automatically on, if you will. And there's a lot of things that what we are saying in these documents. I'm not going to read them aloud, so you can just check them afterwards. But how it works and what it does. So we have a user, okay? Me, Nestori, want to access Exchange online using my Outlook line. So I go to Entra and I said, okay, this is like who I am and I want to use that. And the request to get the access token is a little bit different. So now it's a kind of a signed JWS payload that has the PRT and it's signed with session key. So that kind of proves the identity of the device and me, but also like how Entra should encrypt the tokens. So what happens then, I get the access token and refresh token, but they are encrypted. So it's JWE or JSON Web encryption. So it's a payload that is encrypted using the keys that only the device can decrypt. So even though that there wouldn't be like a man-in-the-middle attack or adversary-in-the-middle attack, and you get access to those tokens, you don't do anything with tokens because they are encrypted. So that's what the token protection does. Okay? Now, when the tokens are back to the endpoint, your operating system is then encrypting them. And then with those encrypted tokens, you can access the actual service. Yeah. So what this means is that token protection protects tokens in transit, but not in rest. So if you're able to compromise user's endpoint, even though that we are using token protection, you can still get those access tokens. So this doesn't protect against those kinds of attacks. So we have this. So token protection prevents adversary-in-the-middle attacks, but that's pretty much it. I do have demo for that too, but let's see how that goes. Okay, you didn't get my password, yes? So let's see, does it work? Okay, now I'm back in the victim's machine. I'm using the nice browser here. Okay, well, let's let it do the thing so we can move forward and then come back to this later to see if we have some telemetry there. So let's go to the last one. So continuous access evaluation, or CEA. I don't know how you pronounce it, but I'm going to say CAE. So again, this is supported by some of our clients and some resources, so not everybody. And you need to have a Entra ID Premium 1. So it's on by default, but you can switch this off if you want to. So you can use conditional access policies to switch this off. But why would you want to do that? Well, we will get back to that later. Okay, so how this works. So me, as a user, okay, I want to use Exchange Online using Outlook. And, and how Entra knows that I support this guy? I need to tell Entra that. Okay, so in the claims attribute, when I'm requesting that token, I said that XMS_CC or capabilities equals capability 1, which Entra knows that, okay, this means guy. And then we will have access token back, a refresh token, and those are valid for up to 28 hours. So it depends. So it can be anything from 20 to 28. So you never know beforehand. But okay, now you go to the service like Exchange Online here, and you give the access token, and that's it. So what's the difference between the normal access token is that now Entra can send event notifications to Exchange Online. Like, for instance, if my password is reset or something like that happens, then that access token doesn't work anymore. So Exchange Online would say that you need to authenticate again. So that's basically how this works. Yes, so Guy may prevent token replay. Now, again, why may? Because we don't support all the clients and resources, so some of those attacks might be like prevented by this technology. Yes, so let's see, is the previous demo alive now? Seems to be. No. Okay, so no demos for you then. Yeah, okay, so what I wanted to show you for this demo is that how threat actors can exploit Guy is that, well, it requires this P1 license so that you can turn it off, but you can request these tokens even though that you don't have P1 license. You just add that capability 1 there to request, and you will get back the Guy token, even though that the organization doesn't have that. So it means that threat actors, if they compromise like your endpoint, they may request a new token that is valid for 28 hours instead of 1 hour. So it's quite interesting technique. And you need to be aware of this, that this could happen, but you can turn it off. So, yeah. And that was going to be my next demo, but I think no demos today. But there's more time for questions, I suppose. So how you can detect that, this abuse? So here's I'm very bad with KQL, but here's a query that allows you to see that has somebody logged in using Guy tokens. It's normal in like a typical setting, but if you don't have like a P1, that's not normal because that shouldn't work. So this is a way kind of like you can see if somebody has been exploiting these. So no demo. Okay, so this kind of a summary and end of the show. So I told you that there are different things that you can do to get your tokens or use the tokens, and those 3 best practices which we can use to protect against them. So the first one was this adversary-in-the-middle attack. So the previous talk was, there was a nice comment that if users are clicking in links and they get compromised, it's not the user's fault. It's our fault who are securing the systems. So if we have this phishing link that leads to adversary-in-the-middle kind of attack, we should have things placed because we can prevent that. So use conditional access policies and token protection. So it's not users' fault if they fail to these kind of attacks. It's us. Then to prevent acquiring tokens using stolen secrets, we can use conditional access policies, like a demand for like a access from safe networks, for instance. And then we can use this Guy to prevent token replay attacks. but there's no mitigation for this part with these best practices. So if a threat actor is able to compromise our users' endpoints, they can steal tokens. They can install malware and so on. So we can prevent that using these technologies. How can we prevent that? No bring your own devices. No admin permissions to users. But that's out of scope of this talk, but anyways. But these technologies doesn't prevent against those attacks. Okay. I don't usually use AI. I hate that. But just for an ending slide, I ask AI to create a Simpson-style angry man with a ponytail yelling at the cloud. So with that, thank you. Yeah, sorry for the demos. So I could have shown them to you like afterwards, but I need to go to the airport right after the talk. So, but yeah, do we have any questions?
Yeah. First, thank you for the talk. So I'm coming from an environment where we're heavily M365 dependent. Your solution, obviously, to us is apply conditional access policies. So do you or anybody else, say from the Microsoft side of the equation, have a good fundamental set of conditional access policies that should be applied, as a recommended baseline?
Yeah, I'd say that I don't know. They probably are, but they are people who are like Microsoft MVPs like Olaf here, who probably knows about that. But at least Fabian Bader, if you know him, he's from German MVP, so he probably have a good set of those. And there are actually some Microsoft managed conditional access policies that are automatically there. Maybe you have seen them. So yeah, so we have something, but that's kind of the thing that I don't know. I know how the technology works, but how to help you guys, I'm not that good at that.
Question here.
Cool.
Thank you for this talk. Looking at the second protection option of binding tokens, there is at least a theoretical framework of sender constraining tokens using MTLS or some cryptographical proofs to bind certificates that are obtained by a certain client to that client, of which the proof is then also repeated when providing the token to the resource provider, the service provider. Is this something that is already supported or that will be supported in the future?
Probably there will be in the future. I don't have the details, but there are other options that we are using here, and but I don't have answers to that. Sorry.
Thank you.
So sorry about the questions also, because I have no answers
Hi.
so far.
Thank you for the talk. It was epic. So the question is about continuous access evaluation. I know that there is only a set of applications, client applications, that are actually compatible with this. Is there a plan to expand this list?
Well, if I remember correctly, our blog post said that yes.
Any specific roadmap or a place where we can see how this will be growing?
Sorry?
How do we know when this will be growing or this list will be getting larger?
Well, I think our marketing department will do that. So there will be blog posts and okay. So on. So when we are expanding that, because that's a good technology. So yeah.
Okay, thanks.
So before, in the previous talk, it was mentioned to democratize security, to ensure that more actors, even those that do not have the large budgets, actually get the necessary security. Why is it that these security features are currently under a P1 license? And can we expect that these security features will become available for all?
Yeah, that's a good question. token protection used to be actually P2, but we changed that to P1 a couple of weeks ago. But to your question, I can say that's an excellent question. Do you have more questions?
Well, yes.
Okay.
If I may?
Yeah, go ahead.
Okay, so looking at the third protection option of Kai.
Yep.
You mentioned that can also be exploited by hackers or attackers because you can actually request them without having that P1 license. Is that like a bug, a feature? Why is that? How can that still be exploited? And can we expect a fix about this in the future?
Yeah, to be honest, it's a technology, so it's just how it works. So probably if you try to report that, it would be like it's by design, which means that it's working as intended. But yeah, that's why I'm here. So I'm telling you that you need to know these things so that you can look for out those things. So that's kind of why I love my job. So I can share these kind of things. So it's not like I wouldn't say that it's a bug as such, but it's just how it behaves. And you need to know that so that you can detect if something happens.
Would you then actually recommend disabling this protection option?
Sorry?
Would you then recommend disabling this protection option?
Did you ask would I recommend to use those?
No, would you recommend disabling the Kai protection option?
Well, it's up to you. So I don't see that as a that big threat, I would say, but some might see that. So, but you can disable that. So, if you have P1.
Yeah, I'm going to check whether we have P1. Thank you very much.
Another one with this idea of making the security like available for everyone. You were saying that one of the recommendations would be bring your own device, so that basically you have controls on the devices. Will a combination, for example, of session control in terms of time and I don't know, CASB, or I don't know, how do you call it, Defender for Cloud Apps, would be something that can be used instead, I mean, to allowing bring your own device?
My recommendation, personal one, is that don't do that, because you never know what's inside like your user's own devices. You have no idea. Even though that you would install some software there beforehand, you never can't be sure about that. But of course we have like things that but it's for the sales guys, these kind of questions, kind of like what technologies or products we have. But that's my recommendation, that don't do that.
Okay, all right, thank you.
Okay, what about the streaming room? Do we have any questions from there?
From the streaming room? Hello? No questions from the streaming room?
Okay, so are we done then? Okay.